the last video. It says use the remainder theorem to determine which of the following binomials are factors of this. So just to remind you, the remainder theorem is it's similar to the rational roots theorem. The rational roots theorem, you can find those factors, right, by using P and Q. The remainder theorem is the one that says if the remainder is 0, then it is a factor of the polynomial. And so that's what we're going to do. We're going to use the rational roots theorem here. Or we could try factoring, but I can see that this isn't going to factor. So the rational roots theorem first. So the rational roots theorem is, we're going to find our P to Q's. And remember, our function is x to the third plus x squared minus 10x plus 8. So we need something that multiplies to 8. All the ways to do that are plus minus 1, plus minus 2, plus minus 4, and plus minus 8. And then over 1, right? So something that multiplies 1 is plus minus 1. So these values are just 1 over 1, 2 over 1, 4 over 1, and 8 over 1. So we don't need to worry about the 1. We're going to use synthetic division. I'm going to go ahead and try 1. 1, 1, negative 10, positive 8. And let's not make an error like I did last time. All right, that's 1 times 1, 1. That's 2. 2 times 1 is 2. That's negative 8 times 1 is negative 8. 0. Boom, I found it right off the bat. I got my 0. That is using the remainder theorem. So this is x squared plus 2x minus 8 equals 0. And one of my roots is this one, x equals 1. Now you could use the remainder theorem again with synthetic division. I'm going to just factor this. So I'm going to factor if it does factor, right? If it doesn't, you have to use something else. So I need something that multiplies to negative 8 and adds to 2. That would be 4 and negative 2. And so this is x plus 4, x minus 2. And so my other two roots are negative 4 and positive 2. So x equals 4 and x equals 2. So 1, 2, 3 roots. And here are my 1, 2, 3 factors, right? So my 3 factors are x minus 1, x minus 2, x plus 4. All right. Okay, so we notice that this function, it says fill in the blanks for the graph below. So first we have to recognize that it's a cubic, right? It has it changes directions 1, 2, 3 times. So this is a degree 3 polynomial. Since it's an odd number, it will behave like a linear function. If it was even, like x to the 4th, an even number, it would behave like a quadratic. So if it were an even, you would look at a. If a is greater than 0, it would be going up, up. If a were less than 0, it would be going down, down, like a quadratic, right? If a is positive, it's facing upward. If a is negative, it's facing downward. But this is a linear, and so it behaves like a line. If a is positive, if a is negative. So like a is like your slope. If a is positive, it's going upward like this. If a is negative, the line is going downward like that. And so our end behavior is it's increasing to the left and decreasing to the right. It's this guy. So this is definitely an odd degree, not an odd function, that's different, but it's an odd degree. The leading coefficient is negative. All right, now we're going to go back to the roots theorem, right? Roots are where this graph crosses the axis. It crosses only at one point. So it has one real root. But remember, it's a degree 3, which means it has 3 roots. The thing is, only one of them is real. So the other 2 must be imaginary. Again, it's got 1 real. It has to have 3 total. So the other 2 are imaginary. All right, I think we're almost done. Number 18, find the inverse function of each. All right, so here we have a quadratic. a cube root, and a square root. I'm going to do these down here. So remember that the steps are the same as number 1. We're going to rewrite it with a y. We're going to switch x and y, and then we're going to solve for y. So we get x minus 4, right? Subtract 4 from both sides, equals y squared, and then we'll square root both sides. Y equals the square root of x minus 4. And then lastly, we write it with function notation. All right, for the next one, y equals the cube root of x minus 1 plus 3. Switch x with y and solve for y. So subtract 3, cube both sides, not cube root, right? Cube both sides. Whoops, this should be a minus 3. And then add 1 to both sides. Rewrite it with function notation. All right, I'll walk through this one more time. So switched x with y, subtracted 3 from both sides, cubed both sides. That would undo my cube, added 1 to both sides, and then rewrote it. All right, the last one, I'm going to rewrite it. I'm also going to change this into a square root. Remember, 1/2 is the same thing as a square root. So this is square root x minus 1. Switch x with y. Solve for y. Add 1 to both sides. Y equals x minus 2 squared plus 1, and then use function notation. All right, and those are all 3 of my functions. And the last one, we're going to solve this. So to solve this, it's a cube root. We want to isolate the radical. Again, we're going to go back to those steps that we started with. Isolate your radical. When I add 5 to both sides, I get 2. And then I would cube both sides to undo the cube root. And then I would add 2 to both sides. And then you can check it. If you plug in 10 under the radical, you're going to get cube root. 10 minus 2 is 8, minus 5 equals negative 3. Cube root of 8 is 2. 2 minus 5, whoops, this should be a 3, my bad, equals negative 3, and that is true. All right, guys, that's all of the videos. I hope you have a phenomenal weekend. I'll see you on Monday.